2 long pieces glued to the plywood top, keep it straight. There's a leg that flips up on a dowel. And at this end, there's a couple of tenons that will fit into the bandsaw. These tenons go into mortises here. And then I've drilled and tapped the wood right through the tenons so that these 1/4-20 screws hold it in place. This piece of wood attaches to the bandsaw with threaded holes that were already there in the base. I use this piece of wood for another purpose, and that's to support the fence. This is quite strong, it doesn't flex, and I can make small adjustments at this end in height by moving the leg to get it dead level with the table. The fence is set parallel to the miter slot, and I don't worry about drift because the bandsaw is tuned up according to the method of Alex Snodgrass, and I'll put a link to that below. Then everything just cuts straight. I've got a Craig fence here, but that's not really important. You could just have a box and clamp that to the table. That would probably even be more secure because there's a little bit of deflection on a high fence like this when I push on it. There's a link below on how I set up this whole fence to make it work well. The blade I'm using is a 1/2 inch carbon steel, 3 tooth per inch in a hook pattern. I wouldn't go any wider than 1/2 inch on a small bandsaw like this 14-inch bandsaw. And Alex Snodgrass actually recommends a 3/8 inch blade with the same 3 tooth per inch hook. I used to just hold the wood against the fence with a push block, move it along like that. I found when I'm doing a lot of it, it gets hard on the shoulder and arm. And also if it's a much bigger piece, longer, heavier piece, then I like to have both hands down here to feed it in. There are bandsaw feather boards that you can purchase. I wanted something more rugged and substantial that could apply more force against the fence. So I built this fixture. I'll put the dimension drawings of it at the end of the video in case you want to make that. The force comes from these spring-loaded hinges, and then this rubs against the wood to keep it forced against the fence. And there's one at the bottom end of the wood and the top end of the wood, and they're adjustable for different heights of wood. I put cork pads on here so that when the piece of wood goes by and it snaps back, it's not so hard. I don't know if they actually make any difference. I've got these blocks of wood that I can put in here to move the pressure bars out of the way when I'm doing a setup with the piece of wood. There's a slot on the top of the hinge to put a screwdriver in to adjust the spring tension, which will control the force applied to the wood. And I've offset the hinges by about 1 inch so that I can access the slot on the bottom hinge to adjust that one. These miter slot things that I've got in there are good for stopping the jig from sliding, but they're not good for stopping it from lifting out. And it may do that because there's forces pushing this way. So I put a clamp here. I would like a clamp on this side as well, but this rail for the fence is in the way, so I can't put that nice piece of wood on. I could maybe put the clamp around here under the bottom of the table. To keep things sliding along nicely, I've got ultra-high molecular weight friction tape on here. I've waxed the fence. This is a piece of Formica on the fence. I've waxed the table and I've waxed the outfeed table. Before cutting into the wood that I'm going to use for the project, I'll do a test cut on a scrap cutoff. Cutting off a thin slice, you're going to have the jig moved in close to the blade, and you want to make sure that the pressure bars don't come in contact with the blade. So I've got about a 1/8 inch gap. Remove the block to let the fingers come down. I've got the springs set to a pretty low tension. I'll see how that goes and then increase the tension if I need to. Piece of wood I'm going to cut, I've jointed this surface flat so it rests flat on the fence, and I've jointed the edge square to that flat surface so that it rests square on the table. I've got a push stick ready so when I get to the end I'm not tempted to put my fingers near the blade. I'm feeding the wood at a rate that the blade wants to cut it. If you push any faster, the blade is just going to deflect like a ribbon would if you pushed on the side of a ribbon, and then you're going to get into a mess. So that's something to kind of get a feel for. I've stopped part way because I want to check something. I'll just raise this guide up. And what I'm checking is that the back of the blade is somewhere centered in the kerf cut, not pushing against one side or the other. If it's pushing hard against one side, then it's going to be drifting and create a non-straight cut. I think it looks okay. So let's examine this piece and see what we can learn. This is the leading edge where I was cutting slowly, and it's very flat. The trailing edge I sped up a bit, and I can see that it's not as flat. I got 1.78 and 1.80, so pretty close. And on the other side, 1.8, 1.79. That's pretty flat. The next piece I want to cut is only 5 inches high, and even when I have this top finger at its lowest point, it's still a little bit too high. So I made this special pressure finger that can reach down. So there I've got the pressure point down lower. Bolt is still up high in the track. For this longer, heavier piece of wood, I gave the screws half a turn, which increased the force considerably, and that'll help keep it against the fence. An in-feed table would be handy for long pieces, but I kind of don't have room for that, but maybe you do. The pressure fingers are doing a good job of holding the wood against the fence, even though I'm guiding the wood with my hands a fair distance from the fence. When I get near the end of the board, I use my right hand to hold it against the fence because the pressure pads are going to become ineffective.